One of the most important parts of this topic is the different forms of equations of a straight line. But before we get into that, we need to understand what is meant by slope of a straight line and how do we measure this. Let us understand this with the help of a simple illustration. So as we see on the board here, we have got the two mutually perpendicular coordinate axes, the x and the y axis, which intersect at the origin O. And there is a straight line at some angle of inclination. So how do we measure the slope of this line? Well, slope is also known as gradient. It can either be called slope or gradient. So just be clear with the terminology. It can be called as slope or gradient, and it is denoted by the letter M. Alright. Now slope of a straight line can be measured as tan theta. M is equal to tan theta or tangent of theta, which is the trigonometric ratio, right? So M, or the slope of the line, can be taken as tan theta. Now what is theta here? Theta is the angle of inclination made by the straight line with x-axis, right? So if you observe, there is some angle between x-axis and the straight line, right? So this angle, when measured in the anti-clockwise direction, let it be equal to theta. So the slope of the straight line can be taken as tan theta, where theta is the angle between the straight line and the x-axis. And remember that the angle here is measured in the anti-clockwise direction from the positive x-axis. So M, or slope, is equal to tan theta. As simple as that. What is the other way of calculating the slope? Well, let's assume that the straight line passes through 2 points A and B. Right? So let the point A be at this position and this be the point B. Alright, so the straight line passes through the 2 points A and B, where the coordinates are x1, y1 and x2, y2 respectively. Alright, now if at all the 2 points through which the straight line passes through is given to us, then the slope can be taken as y2 minus y1 divided by x2 minus x1, where y2 minus y1 is the difference of y coordinates of the 2 points and x2 minus x1 is the difference of x coordinates. So the difference of coordinates by the difference of abscissa, right? So the slope of the straight line or gradient of a straight line is equal to tan theta, which is equal to y2 minus y1 by x2 minus x1. Now, how do we get this equation y2 minus y1 by x2 minus x1? It's very easy to understand. If you look at the 2 points A and B, which are marked as shown here, and the coordinates x1, x2, y1, y2, we see that the straight line here with respect to x-axis, as we have seen, makes an angle of theta. Alright, the angle theta here will be same, because anyway these two are parallel lines. The x-axis is just, let's say, shifted upwards, right? So the angle theta remains the same. Now if you look at the coordinates x1, y1, x2, y2, what do we see? Let's look at this vertical distance, right? So if we drop a perpendicular here, what is this? This is y2, right? The vertical distance of point B is y2, and point A, right? The vertical distance is y1. Are you able to follow? This vertical distance here is y1. If this is y1, this also would be equal to y1. Alright. And the complete distance is equal to y2. This is equal to y2. So what is the distance between this straight line and the point B? It will be equal to y2 minus y1. Alright. This dotted line can be measured as y2 minus y1. That is the total distance minus y1. Likewise, this portion here, that is the horizontal distance, can be taken as x2 minus x1. Are you able to follow? Because the horizontal distance of point B is x2, right? From y-axis, horizontal distance is the distance from y-axis. So from y-axis, the point B is at a distance of x2 and the point A is at a distance of x1. So we can say that from this point to this point, the difference is going to be x2 minus x1. Now what is tan theta, the trigonometric ratio tan theta? It is opposite side by adjacent side. In a given right angle triangle, tan theta can be taken as opposite side by the adjacent side. Now in this right angle triangle, right, BA, and let's say this point here is C. In this right angle triangle BAC, what do we see? Tan theta will be equal to opposite side. The opposite side is y2 minus y1 and the adjacent side is x2 minus x1. So that is the reason the slope can be measured as y2 minus y1 by x2 minus x1, where x1 y1 and x2 y2 are the coordinates of the 2 points A and B through which the straight line passes through. and it can be any 2 points on the straight line, right? So once we know the 2 points through which a straight line passes through, we can simply measure the slope as y2 minus y1 by x2 minus x1. And if the angle of inclination from the x-axis is given to us, then it can be taken as tan theta. So this is what is meant by slope or the gradient of a straight line. Now that we have learned what is meant by slope of a straight line and how to measure it, let us look at the different forms of equations of a straight line. And we shall start with the general form of equation. But let us first understand what is meant by an equation of the straight line. Well, an equation of a straight line is a relationship between x and y, which is satisfied by the coordinates of each and every point that lies on the straight line. We know that a straight line passes through a number of points. So an equation should be the one which is satisfied by the coordinates of all those points which lie on the straight line. Let us look at the general form of the equation. So as you see here, the general form is ax plus by plus c equals to 0. Right? It is a simple linear equation in terms of two variables x and y, and a, b and c are the coefficients. So x and y are the variables and a, b, c are the real coefficients. So this is the general form of equation of a straight line, or a simple linear equation in terms of x and y. Now the slope of the straight line can be determined from the equation of the line, right? If we know the equation of the line, or if the equation of the line is given to us, we can find out the slope of the straight line without doing any sort of calculation. Let's look at how do we do that. Now, slope of a line is equal to minus of the coefficient of x divided by coefficient of y, where x and y are the variables. Right, so if you look at the general form, it is ax plus by plus c equals to 0. So we can say the coefficient is minus a by b, where a is the coefficient of x and b is the coefficient of y. So if we have a linear equation, which is the equation of a straight line, we can say the slope of the line is minus a by b. It is equal to m, right? In general, we denote the slope as m. So m can be taken as minus a by b. Now, apart from the general equation of a straight line, or the general form of equation of a straight line, there are a few important equations which we need to understand clearly. Let's have a look at them. For example, the equation of x-axis. What will be the equation of x-axis? Now, x-axis is also a straight line. Yes or no? Out of the two coordinate axes, the horizontal axis is x-axis, which is nothing but a straight line. So what is the equation of x-axis? Right. The equation of x-axis is y equals to 0. Y equal to 0. As simple as that. Now, why do we say the equation of x-axis y equal to 0? Because on x-axis, the y coordinate is always equal to 0. Right? Y coordinate denotes the vertical distance of the line from x-axis. For x-axis, the vertical distance from x-axis is 0. Hence, y equals to 0. And that gives us the equation of x-axis. Let us understand this with the help of the coordinate axis. Right? Let's say these are the x and y axis respectively. Right? Mutually perpendicular axis meeting at the origin O. Now, we are looking at the equation of x-axis. Right? The equation of x-axis will be simply y equal to 0. It can be taken as y equal to 0. Because the y coordinate of any point on the x-axis will be 0. The vertical distance is 0. Right? Vertical distance, which is y coordinate, is 0. So y equal to 0 gives us the equation of x-axis. What about the slope of x-axis? We know that in general form the slope is minus a by b. What about the slope of x-axis? Now if you look at it, we have got no x variable at all, right? There is no x variable here, right? We don't have the x variable. Now the coefficient of the slope of a line can be taken as coefficient of x by coefficient of y. What is the coefficient of x? 0. Hence the slope of x-axis can be taken as 0, right? So the slope of x-axis will be equal to 0. There is another way to understand why the slope is 0. We have understood that slope is tan theta, where theta is the angle made by the line with x-axis. Now for x-axis, what is the angle made by x-axis? 0. Right? What is the angle of inclination? 0. There is no inclination for x-axis with x-axis, right? It is one and the same. So angle is 0, which is tan 0. Tan 0 is equal to 0. Hence we can say the slope of x-axis is 0. So the equation is y equal to 0 and the slope is equal to 0. How about the equation of y-axis? Now this should be easy. Since we have learned what is the equation of x-axis, equation of y-axis should be simple. Equation of y-axis is x equal to 0. Now why do we say the equation is x equal to 0? Because on y-axis, the x coordinate is always 0. You take any point on y-axis, x coordinate will be equal to 0. So a simple equation here is x equal to 0. Right? What is x? X coordinate is a horizontal distance. Now what is the horizontal distance of y-axis? 0. Right? There is no horizontal distance. It is the y-axis itself. Hence the horizontal distance is 0, which means x equal to 0. And now let's look at the slope. What is the slope of y-axis? Well, the slope of y-axis is undefined, right? Slope here is undefined. We cannot talk about the slope of y-axis. What is the reason? Understand, if you go by the theta, tan theta there, we know that y-axis makes an angle of 90 degrees with x-axis. So theta is equal to 90. But what is tan theta? Undefined, right? So slope of y-axis should be taken as undefined. Or if you go by the formula here, we know that it is coefficient of x by coefficient of y. Negative of coefficient of x by coefficient of y. What is the coefficient of x? 1. What is coefficient of y? 0. Right? There is no y variable here. So 0. So minus 1 by 0. What is 1 by 0? It's undefined. So slope here is undefined. So that's about the equation of the coordinate axis. X-axis y equal to 0 with a slope of 0, and y-axis x equal to 0 with a slope which is undefined. Let us also look at the equation of lines which are parallel to x-axis and y-axis. Right? Let's say a line parallel to x-axis. Any line that is parallel to x-axis. What will be the equation? Right? Equation of a straight line which is parallel to x-axis. So we have seen the equation of x-axis is y equal to 0, equation of y-axis is x equal to 0. Now let's look at a line which is parallel to x-axis. So these two lines will never meet each other. There is a distance. There is a constant distance between these two lines. Let us assume that distance is k. Right? The distance here is k. Now how do you get the equation of this line? See, for x-axis the equation is y equal to 0 because the y coordinate is 0. Right? The vertical distance is 0. But for this line, what is the vertical distance? It is k, right? It is k units. K is the distance of the line from x-axis. So we can say the equation of a line parallel to x-axis will be y equals to k. Yes or no? So this can be taken as y equal to k. And slope, however, would remain 0, right? Slope of x-axis or any line parallel to x-axis is 0, because even this line which is parallel to x-axis makes an angle of 0 degrees, right? What's the angle here? Theta, 0. Theta is 0, tan theta will be 0. So the slope will be 0. Right? So the line parallel to x-axis can be given by y equals to k, where k is the vertical distance, right? K is nothing but the y coordinate or the vertical distance of the line from x-axis. Now, a line parallel to y-axis. Line parallel to y-axis, and since we have already looked at a parallel line to x-axis, this shouldn't be difficult. What do we do? X equals to k. X will be equal to k, and slope undefined. Right? So for example, let's say there is a line which is parallel to y-axis. Let's look at this line, right? It is parallel to y-axis. So there is a constant distance between y-axis and this line. Let that distance be k, some constant k, or you can take any other constant there. So the distance is k. So what will be the equation? See, y-axis x equal to 0, right? On this line x will be equal to 0. But this line is cutting x at what point? At k. Like the earlier case, this line parallel to x-axis was cutting y-axis at a point k, and likewise this line here is cutting x-axis at a point k. So we can say the equation of this line is x equals to k. Right? So for y-axis x is 0, and for any line which is parallel to y-axis x equal to k will be the equation. So we can say x equal to k is the equation, and slope remains undefined. Why? This line is making an angle of 90 degrees with x-axis, tan 90. Undefined, right? Or simply we know that the slope of a line is coefficient of x by coefficient of y. What is the coefficient of x? 1. Coefficient of y? 0. 1 by 0, undefined. So simply go by either the formula, which is minus of coefficient of x by coefficient of y, or tan theta, and these represent the general form of equation of a straight line. Having learned the general form of equation of a straight line, let us now look at the other various forms in which a straight line can be represented. And we shall start with the slope-intercept form. So let's understand what is meant by slope-intercept form. Right? Now in the slope-intercept form, we are given the slope of the line and the y-intercept. In that case, the equation can be taken as y equals to mx plus c. Right? Where m is the slope of the line and c is the intercept that is cut off by the line on y-axis. Now, what is an intercept? Let's understand this with the help of a simple graph. Let's say these are the coordinate axes, the x and the y-axis, right? And we have a straight line as follows. Now, the slope of this straight line is given as m. The slope is m. And the y-intercept is c. What is meant by intercept? Well, intercept is nothing but the distance between the origin and the point where the line cuts on the given axis. Like in our case, we say that y-intercept is c, right? Which means, let's say the line here cuts y-axis at this point. So the distance between origin O and this point of intersection of the line with y-axis is known as the y-intercept, which is given as c. So once the y-intercept and the slope is given, the equation of the line can be taken as y equals to mx plus c. So m is the slope and c is the y-intercept, and x and y are the variables. This also is at times referred as the general form of the equation of a straight line, right? It can be compared with ax plus by plus c equals to 0. Let us now take the next form, that is the slope point form. Let us see how do we represent a line in the slope point form. Like in the earlier case, we know that the slope-intercept form can be taken as y equals to mx plus c. So the slope and the intercept were given to us. And in this case, when the slope and the point through which the line passes through is given, then we can take the slope-intercept form, which is given as y minus y1 equals to m into x minus x1. Let's say the question says that a line passes through a point x1, y1 and its slope is m. Then the equation of the line can be taken as y minus y1 equals to m into x minus x1. So instead of giving the y-intercept, we are given a point. Let's say a point A, the coordinates of which are x1, y1. So if the point A and the slope is given, then we go ahead with slope point form, which is y minus y1 equals to m into x minus x1. Alright? Let us now take the next form, which is two-point form. Two-point form. So as the name says here, instead of giving the slope, we are given 2 points through which the line passes through. Right? Earlier in the slope-intercept form, we are given the slope and the y-intercept. In slope point form, the slope and a single point. But in two-point form, we are given 2 points through which the line passes through. And we need to find out the equation, which can be taken as y minus y1 equals to, now it should be similar to slope point form, right? Equation is y minus y1 equals to m into x minus f1. So y minus y1 equals to m. Now what is m? Slope. We know how to measure the slope of a line when 2 points are given. How do we take it? y2 minus y1 by x2 minus x1. So m can be replaced with y2 minus y1 divided by x2 minus x1 into x minus x1. So if you look at slope point form and 2 point form, they are similar to each other. Y minus y1 equals to m into x minus x1, where m is the slope. The slope was directly given to us. But in 2 point form, the slope is not given. Instead, the other point is given. And we know how to measure the slope when both the points are given to us. So y minus y1 equals to m. The slope can be taken as y2 minus y1 by x2 minus x1 into x minus x1. So this is known as 2-point form. So when 2 points are given and need to write the equation, we can take it as y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. Right? So 1 point and some other point. Let's say this point is B. The coordinates are x2 and y2. So we can take the equation of the line as given here, y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. Next comes the intercept form. Let us understand what is meant by intercept form of a line. Now we have already understood what is meant by intercept. In slope intercept form, the slope was m and the intercept was c. What is intercept? Intercept is the distance from the origin to the point where the line meets the given axis, right? For example, here the line cuts y-axis at this point. So the distance between origin and this point is c, which is known as the intercept. So in intercept form, both the intercepts are given. The intercept made by the line with x-axis and and with y-axis, and we need to write the equation of the line. So let us understand, or let us see how the graph looks like. Let's say these are the x and the y-axis, and there is a straight line which is as shown here. Now if you see, the straight line cuts x-axis at one point and y-axis at another point. Okay, so here is the origin, and let's say the point where it cuts x-axis is A, and the point where it cuts y-axis is B. So what is the x-intercept? X-intercept can be taken as OA, right? We know that intercept is the distance between origin and the point where the straight line cuts the axis. So x-intercept, it cuts x-axis at A. So this distance OA can be taken as x-intercept. Likewise, what will be y-intercept? It will be equal to OB, right? From the origin to the point where the straight line cuts y-axis. Let us assume the distances are A and B, right? This is A and this is B. So the x-intercept is A and the y-intercept is B. So this is equal to A and here is B. So how do we get the equation of line intercept form? It can be taken as x by A plus y by B equals to 1. Alright, so when both the intercepts are given, we can write the equation of the line as x by A plus y by B equals to 1. So these are the different forms of equations of a straight line. Slope intercept form where the slope and intercept is given. So it can be taken as y equals to mx plus c. The slope point form where the slope and a point is given, which can be taken as y minus y1 equals to m into x minus x1. 2-point form, 2 points are given. Alright, 2 points and the coordinates for both the points, right? x1 y1 and x2 y2. The equation can be taken as y minus y1 equals to y2 minus y1 by x2 minus x1, which is the slope, into x minus x1. And the last one here is intercept form, where both the intercepts are given, the x-intercept and the y-intercept. Equation can be taken as x by A plus y by B equals to 1. So these are the different forms of equations of a straight line. Now before we move ahead, let us take a special case of one of these forms, and that is the slope-intercept form. We know that the equation of a line in slope-intercept form is y equals to mx plus c, where m is the slope of the line and c is the y-intercept, that is the distance between the origin and the point where the line cuts y-axis. Now what happens if the y-intercept c is equal to 0? What do we understand when the y-intercept is 0? Let's look at this with the help of a simple graph. Let's consider the original graph here, right? These are the coordinate axis, x and y axis, and we know that there is an intercept, y-intercept, which is equal to c. And the line, as you see, passes through the y-axis and cuts it at a particular point. But if c is equal to 0, it is clear that the distance between origin and the point of intersection of the line with y-axis has to be 0, right? If c is equal to 0, means this gap between origin and the point of intersection should become 0. When is that possible? Only when the line passes through the origin. So the point to be noted is, if the y-intercept is 0, then we can conclude that the line passes through origin. And the equation of that line would become y equals to mx, since c equals to 0. Alright, so if c becomes 0, then the line passes through the origin. So this line can be taken as y equals to mx, since the y-intercept is 0. Understand, there is no other way that the line can cut y-axis. It has to cut y-axis only at origin. Hence the line passes through origin is the conclusion that we can make when c equals to 0. And the equation of the line becomes y equals to mx. Now, even if take at any other point, let's say if we assume that the straight line is as follows. Now in this case, what do we see? There is still a y-intercept, right? Understand, intercept does not mean that it has to be only on the positive y-axis or positive x-axis. Intercept is the distance of the origin, distance between the origin and the point where the line cuts the axis. Now here you see that this line cuts y-axis at this point. So the distance from origin to this point is considerable. There is some intercept, let's say c dash. Hence this cannot be y equals to mx. It has got a considerable intercept. Alright, so intercept is 0, means it will neither be cutting y-axis on the positive side nor on the negative side. So the only option possible is it has to pass through origin, and such a line can be taken as y equals to mx. So that's one special case which shows that the line passes through origin. Or when the equation is given as y equals to mx, we can conclude that the line passes through origin. And that applies even in the second form. If you look at the slope point form, it is y minus y1 equals to m into x minus x1. Slope and the point is given. In this case, as we have seen, the point is origin. Alright, so origin means what? y1 and x1 both are 0. So what do we get? Y minus 0 equals to m into x minus 0. So that again gives us y equals to mx. So clearly, if the line passes through origin, the equation of the line would become y equals to mx. And as and when the theta changes, right? Y equals to mx. The angle here is theta. Angle of inclination of the line with x-axis is theta. So as and when theta changes, the gradient or the slope, that is m, also changes. Equation will remain y equals to mx. Now that we have learned how to write the equation of a straight line in different forms, let us look at a few conditions. These conditions will help us decide if the given lines are parallel and perpendicular. So let's look at the statement here. Two lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So as we see, we have taken the equations in the general form. The general form, as we all know, is ax plus by plus c equal to 0, where a, b and c are the constants, right? So here in the first line, a1, b1 and c1 are the constants, and in the second one it is a2, b2 and c2 that are the constants. So these two lines are, point number 1, coincident. Now what does it mean by two lines being coincident? It means the lines lie on top of each other, right? So when you draw these two lines on the paper or on the graph, we will be able to see only one single line because both the lines are on top of each other, right? Not just lines. Any geometrical shapes being coincident implies those two shapes lie on top of each other or are exactly the same. So the two lines are coincident if a1 by a2 equals to b1 by b2 equal to c1 by c2. Right, so the ratio of the coefficients a1 by a2, b1 by b2 and c1 by c2 has to be equal. Or we can say that the ratio of the coefficients of x should be equal to the ratio of the coefficients of y should be equal to the ratio of the constants c in both the lines. Point 2. The two lines are parallel if slopes are equal, right? So that's easy to understand. If the slopes are equal, implies the lines are parallel. They have got the same inclination with respect to the positive x-axis. So if the inclination is same, obviously the two lines would be equal. So the two lines are parallel if the slopes are equal. Now what is the slope of line number 1? Minus a1 by b1, right? We know that the slope of a line can be taken as minus of the coefficient of x by coefficient of y. So minus a1 by b1. Now slopes have to be equal. So minus a1 by b1 should be equal to minus a2 by b2, right? Minus a1 by b1 equal to minus a2 by b2, which when further simplified gives us a1 by a2 equals to b1 by b2. So simply, if the ratio of the coefficients of x is equal to the ratio of coefficients of y, then we can conclude that the two lines are parallel. And this is when it is given in the form, in the general form. Let's say the equations of line are given in slope-intercept form. Y equals to mx plus c, right? So there are two lines. Y equals to m1x plus c1 and y equals to m2x plus c2. So when do we say that the two lines are parallel? If m1 is equal to m2. Simply, the condition here is the slopes have to be equal, whatever be the form of the equation, right? So if the slopes are equal, the two lines are parallel. And finally, the two lines are perpendicular, right? What does it mean by lines being perpendicular? They intersect each other at an angle of 90 degrees, right? So the two lines are perpendicular if the product of the slopes is minus 1. Right? The two lines will be perpendicular if the product of their slopes is equal to minus 1. So in the slope-intercept form, y equals to m1x plus c1 and y equals to m2x plus c2. When do we say the two lines are parallel? If m1 into m2 equals to minus 1. But since we have taken the equations in general form, let's come to a conclusion here, right? The product of the slopes is minus 1. What is slope here? Minus a1 by b1. Slope in the second case, minus a2 by b2. This product has to be minus 1. When simplified further, we get a1 a2 plus b1 b2 equal to 0. So the point here is, we can now conclude saying that the two lines would be perpendicular if the product of the coefficients of x when added to the product of coefficients of y will result in 0. Or simply remember a1 a2 plus b1 b2 equal to 0. But the basis of this condition is that the product of the slopes is minus 1. So simple points here, the lines are coincident if a1 by a2 equals to b1 by b2 equal to c1 by c2. Lines are parallel if their slopes are equal, and they are perpendicular if the product of their slopes is equal to minus 1. So before we take up questions based on straight lines, let us also learn how to measure the distance between a point and a straight line and the distance between two parallel lines. So the first one here is the distance of a point from a line. The statement says the length of a perpendicular from a point a x1 y1 to a line ax plus by plus c equal to 0 is given by modulus of ax1 plus by1 plus c divided by root over a squared plus b squared. So there is a point which is a of x1 comma y1 and a line which is given by the general form ax plus by plus c equal to 0. Now if you drop a perpendicular from the point to this straight line, or if you have to measure the distance between the point and the straight line, we take it as ax1 plus by1 plus c modulus of divided by root over a square plus b square, right? So how does it look like when you put it on a graph here? Let's say this is a straight line, right? This is a line described by ax plus by plus c equal to 0, and we have a point, point A. This is the point A, which is a of x1 comma y1. So when we have to measure the distance between the point and the line here, right, we drop a perpendicular. The shortest distance always is the perpendicular, so we just drop a perpendicular which is, as shown here, angle is 90 degrees. So when we drop a perpendicular, we get the distance between the point and the line as ax1 plus by1 plus c divided by root over a square plus b square. So this is the distance, right, from the point A. This is the point A to the point where it meets on the given line. So ax1 plus by1 plus c divided by root over a square plus b square. And be careful, the numerator has to be in modulus, which means we always take the positive value here. Distance cannot be negative, right? And the second point here is distance between two parallel lines, right? So if ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 are parallel lines, right? If these are two parallel lines, then the distance between these lines is given by modulus of c1 minus c2 divided by root over a square plus b square. So two lines expressed in the general form, ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. These two are parallel. Obviously they are parallel because the ratio of coefficients of x, a by a, is equal to the ratio of coefficients of y, b by b. Right? See, when the equations are given, it need not be exactly in this form. But when we try to simplify it, we'll find that the ratio of coefficients of x and the ratio of coefficients of y would be equal. Those two lines are parallel. So in that case, we only need to consider the constants c1 and c2 in the formula. So modulus of c1 minus c2 divided by root over a square plus b square will be the distance between these two parallel lines. As a special case, let us also see what will be the length of a perpendicular from origin to a given line. Here the point is x1 comma y1, but let's say we have to find out the distance between the origin and a given line. How do we measure it? It is given by the same formula, ax1 plus by1 plus c divided by root over a square plus b square. But x1 and y1 both are 0. Since the point is origin, the coordinates are 0. So if x1 is 0, ax1 becomes 0. y1 is 0, by1 also becomes 0. So what are we left with? C divided by root over a square plus b square. So we can also understand that the distance between origin and a line is given by c, or modulus of c divided by root over a square plus b square. The next one here is distance between two parallel lines. So let's see how do we get the distance between two lines that are parallel. So ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 are two parallel lines. Alright, obviously they are parallel because the ratio of coefficients of x, a by a, is equal to the ratio of coefficients of y, b by b. A by a equals to 1, b by b equals to 1. See, when the question is given and the two equations of lines are given, it need not be equal. The ratio of coefficients of x may not be equal and the coefficients of y also may not be equal. But it is obvious that when we take, we can take something common in one of the equations to make sure that they become equal. Yes or no? Since the two lines are parallel, obviously the ratio has to be equal. So we can take common in one of the equations, some value common in one of the equations, such that the coefficients of x and y become equal. Now, when these two lines are parallel, then the distance between these lines is given by modulus of c1 minus c2 divided by root over a square plus b square, right? So c1 and c2 are the constants there in both the lines. So c1 minus c2, modulus of c1 minus c2 divided by root over a square plus b square. A and b are the coefficients of x and y in the two lines respectively, right? So modulus of c1 minus c2 by root over a square plus b square will give us the distance between the two parallel lines. And you very well understand that the distance between two parallel lines is always constant, right? Because the lines are parallel, they would never intersect, right? Their slopes are equal. So the distance remains constant throughout the lines there. Okay, so these points may be helpful in answering questions which are based on finding out the distance between a point and a line or distance between two perpendicular lines. So simply substitute the values in the formula and you will get the right answer.